Hello students. Now we have reached the last module of syllabus of Mumbai University, which is kinetics of particles. We learn this kinetics of particles means what here we consider the motion of the objects without dimensions, but with the forces causing motion. We have already learned the 3 chapters of dynamics. In the first 2 chapters, we had learned the motion of the objects without dimensions and without forces. That is under kinematics of particles. Then we learned kinematics of rigid bodies, where we studied the motion of the objects with dimensions but without forces. In the 3 chapters which we have learned so far uh, uh, in my lectures, we did not consider the forces causing motion. In this module, in this part, in kinetics of particles, we'll study the motion of objects without dimensions, but with the forces causing motion. In every problem, you'll see that the forces causing motion are given and the mass or the weight of the object is also given. We learn this chapter under 3 heads. 3 different concepts are there. So we will be learning this chapter. Basically, it is one chapter, but we will be learning under 3 heads. So I have made actually 3 chapters in my book about kinetics of particles. First part is Newton's law, D'Alembert's principle. Second is work energy principle, and third is impact and impulse and momentum. Now, in this chapter, we are giving the heading is what? Newton's law and D'Alembert's principle. It is first lecture. We will learn each concept. Newton's law will be covered in 2 video lectures. Work energy will be covered in 2 video lectures. Even impact will also be covered in 2 lectures. But in my book, Newton's law is given as a chapter, that is under the head Kinetics of Particle Part 1. This is given in my book as Kinetics of Particle Part 2. This is given in my book as Kinetics of Particle Part 3. So now we are on the chapter, that is chapter number 9 in the book, Kinetics of Particle Part 1, where heading is Newton's law and D'Alembert's principle. So let's understand Newton's law. We have already studied Newton's second law, that is F is equal to m. So this chapter is based on Newton's second law. Let's consider a particle of mass m, which is acted upon by 2 forces F1 and F2. Resultant of these 2 forces sigma F, and as it is of mass m, resultant of the force acting on the particle is sigma F. Particle will start accelerating in the direction of resultant force, and let A be the acceleration of the particle. We apply Newton's law, sigma F is equal to ma. This gets you the acceleration of the particle or the body. Right? In this chapter, we will be coming across the bodies without dimension. We'll come across the bodies without dimensions. So we will be treating them as particle only. Now, Newton's law can be expressed in component forms, as sigma F can be resolved into sigma Fx and sigma Fi. Sigma Fx is the component of resultant in x direction. Sigma Fi is the resultant component in y direction. As similarly, acceleration can be resolved as ax and ay. Ax is acceleration x direction, ay is acceleration y direction. You can apply the Newton's law in component form, that is sigma Fx is equal to max, that is Newton's law in x direction. Sigma Fy is equal to may, that is Newton's law in y direction. This is all is Newton's law, which we all are familiar also from our previous levels also. Now comes to D'Alembert principle. What is D'Alembert principle? D'Alembert principle is nothing but modification over the Newton's law. Newton's law, F is equal to ma, sigma F is equal to ma. What D'Alembert suggested that product of mass and acceleration is a force. He said that when you write sigma F, then m into a is a force. Why it is on the right side? He said that when you write sigma F, so ma, he gave the name to the product of mass and acceleration as inertia force. He gave the name to the product of mass and acceleration as inertia force, and he said that inertia force acts in the direction opposite to that of acceleration. Then he said the resultant of sigma F and inertia force, that is minus ma, since it acts in the direction opposite to that acceleration, is 0. So basically ma, which was on the right side, he brought it on the left side. So if you bring it on the left side, definitely it will be minus. And he named it as inertia force. So he says resultant of sigma F and minus ma is equal to 0. And he named it as D'Alembert principle, or it was also called as equation of dynamic equilibrium. So as Newton's law can be expressed in component form, similarly, D'Alembert principle can also be expressed in component form. Like in x direction, sigma fx minus max is equal to 0, and in y direction, sigma fy minus may is 0. All right. So this is D'Alembert principle. Don't you think so that Newton's law and D'Alembert principle are one and the same thing? It is only the difference is in the presentation. When you apply Newton's law, you are solving the problem by Newton's law. Product of mass and acceleration is not shown as a force on the free body diagram. Whereas if you are solving the problem by D'Alembert principle, product of mass and acceleration is an inertia force which is shown on the free body diagram in the direction opposite to that of acceleration. Now, sign convention. While applying Newton's law, forces in the direction of acceleration are taken as positive. Why? Why we take force in the direction of acceleration as positive? Because if there is a particle which is acted upon by number of forces, it will start accelerating in the direction of resultant force. So resultant force, in the direction of resultant force, it will accelerate. So in that direction only we'll take all the forces as positive. So direction of resultant force is nothing but direction of acceleration. So we will remember it like this. While applying Newton's law, force in the direction of acceleration are taken as positive. Another thing is about the units part. In kinetics, mass is taken in kg and forces are taken in newtons only. When you are solving the problems of statics, you take forces sometimes in Newton and sometimes in kilonewton. But when you are solving the problems of Newton's law or kinetics of particle, that is Newton's law or work, energy or impact, you should take mass always in kg and you should take the forces always in Newton. We are ready to start with the problems on this chapter. Initially, we'll have short problems which are asked for 4 marks. I'll discuss 4-5 problems of this type. Problem number 1. The 550 Newton box rests on a horizontal plane for which the coefficient of kinetic friction mu k is 0.32. If the box is subjected to a 400 Newton towing force as shown, find the velocity of the box in 4 seconds starting from rest. This is the box which is given to you, on which 400 Newton force towing force is applied. Now we draw the free body diagram of this block. When you draw the free body diagram of the block, you can see that all blocks, bodies, objects in this chapter will be given to you without dimension. That means you have to consider that it is a particle. That means it is all forces are concurrent. All right. Now we consider FBD of the block. Weight will be vertically down 550. Normal reaction will be there as in friction chapter. Motion is to the right, friction is to the left. Friction is mu k and mu. This 400 has been resolved, 400 cos 30 and 400 sin 30. As students, motion of this block will be along the plane. There is no motion normal to the plane. So still the box is considered to be in equilibrium in y direction. So we apply sigma Fy is equal to 0. Sigma Fy is what? N1 plus 400 sin 30 is equal to 550. N1 upward plus 400 sin 30 is 550. That gets N. Now you apply Newton's law in x direction. Sigma Fx is equal to M. Forces in the direction of acceleration are taken as positive. So as we understand, the force causing motion is being applied to the right, there will be acceleration to the right. So more forces must be towards right. So let's take towards right forces positive. Sigma Fx is equal to Ma. 400 cos 30 is positive. Minus 0.32 N1 is equal to Ma. M is what? Weight is 550. So W is mg. So M is what? W upon G. 550 upon 9.81 into A. Put the value of N1 over here. You get the acceleration. Once you get acceleration, you got it positive. That means it is in the direction in which you have taken acceleration. Now we apply equations of motion as acceleration is constant. Why you assume that acceleration is constant? You'll see that in majority of the problems in this chapter, all forces on the free body diagram is constant. So obviously acceleration will also be constant. Let's apply equation of motion. V is equal to U plus 8. Particle starts from rest. Acceleration 4.181 and time is 4. So 16.724 meter per second. Now this explanatory note. I have already discussed this explanatory note, but still I'll just elaborate once again. As in the given problem, motion of the box is along the plane. There is no motion normal to the plane. So we still apply sigma Fy is equal to 0. All right. Then another point is that in the entire chapter, you'll see the dimensions of the body or object. If the dimension of the body or object are not given, it is treated as a particle. That's what I have already told you, like in the given problem on this screen, dimension of the box are not given, so it is treated as a particle. And in fact, as per your syllabus, you have kinetics of particles only. You will not come across any problem of the kinetics of rigid bodies. That entire analysis of kinetics of rigid bodies is different. So that is not in MU syllabus. So you will be given the objects or the bodies without dimensions only. Now, next we come to the Newton's law. See the students, Newton's law or D'Alembert principle, as in the previous slide we discussed, are one and the same thing. It is just only a matter of presentation. When they ask you to define Newton's law or they ask you to define D'Alembert principle, they are definitely different when you are defining them. But when it comes to the solution of the problem, both are one and the same thing. So even whether they ask, write it in the examination, solve the problem by Newton's law, or they say that solve the problem by D'Alembert principle, you have to consider one and the same thing. As students, you are familiar from the previous level with Newton's law. So we'll adopt Newton's law only for solving all the problems in this chapter, whether they write solve by Newton's law or they write by D'Alembert principle, because we have understood both are one and the same thing. It is a slight difference in the presentation only is different. All right, let's move to the next problem. Let's come to problem number 2. A motorist traveling at a speed of 90 km/h suddenly applies the brakes and comes to rest after skidding 100 meters. Determine the time required for the car to stop and coefficient of kinetic friction between the tires and the road surface. Now we take to say motion is happening towards right. Initial velocity is 90.3.6, that is 25 meters per second. It comes to rest after traveling distance of 100. So S is 100. Easy. We are, as V and S are into consideration, we apply equation of motion. V square is equal to U square plus 2S. V 0, U is 25, S is 100. So you get acceleration. Acceleration comes negative. Negative acceleration means what? It is not in the direction of motion. It is in the direction opposite to that of motion. That means negative means acceleration is towards left. Let's apply equation of motion. V is equal to U plus AT. Since we want to find the time what it takes in coming to rest. So V is 0, U is 25, acceleration is minus 3.125 into T, that comes out to be 8 seconds. Now let's draw the free body diagram of the motorist so as to find the coefficient of kinetic friction. When you draw its free body diagram, you show the weight vertically down. Mass is not given, weight is not given, so we have written weight as 9.81 m. In any problem of Newton's law, if mass or weight are not given, then you take it as weight as in terms of mass only. Because when you apply Newton's law, mass gets cancelled. So normal reaction vertically upward, acceleration is to the left, as motion is to the right, friction is also to the left. So now your free body diagram is complete with all forces. Let's apply sigma Fi is equal to 0, N1 is equal to 9.81 m, right? Sigma Fx is equal to ma. There is only force acting on this box is mu k N1. So sigma Fx is equal to mu k N1 is equal to ma, m into a. Mm gets and put the value of N1 9.81 m. Mm gets cancelled, you get mu k as 0.32. So this way you get the coefficient of kinetic friction between tires and the road surface. When you apply the Newton's law, forces in the direction of acceleration are taken as positive. Now, problem number 3. A 500 Newton crate kept on the top of 15-degree sloping surface is pushed down the plane with the initial velocity of 20 meters per second. If mu(s) is 0.5 and mu(k) is 0.4, right? Well, students, here one point what should be observed that many times in our examination problems, they give mu(s) and mu(k) both. But it is not necessary that both are to be used in the problem. Sometimes you'll observe that only mu(s) is only required, but mu(k) is redundant data. Sometimes mu(k) is only required, mu(s) is redundant data. Right? So keep that in mind. It's not necessary that both are to be used. So like in this problem, mu(s) is not required in the problem, but it's given. So we'll just ignore that. Well, students, we draw the free body diagram of the crate. Weight will be vertically down, that is 500 Newton. Normal reaction will be towards the body. All right. Motion is down the plane. Acceleration is also down the plane. As motion is down the plane, friction is up the plane, 0.4 N1. Uk is 0.4. Right. We are considering motion. So we mu k N1. Now weight is resolved. Weight is vertically down. Plane is making 15 degree with horizontal. Normal will make 15 degree with vertical. So this is 500 cos 15. Normal to plane component. And this is 500 sin. We can definitely apply sigma Fi is equal to 0. So N1 is 500 cos 15. Sigma Fx is equal to ma. As body will accelerate down, so downward forces must be more. So we'll take them positive. 500 sin 15 positive minus 0.4 N1 is equal to ma. M is what? 500 upon 9.81 into a. Substitute the value of N1 as 500 cos 15. You get acceleration. Again, acceleration comes minus. Minus indicative what? It is not in the motion is downward, but acceleration we took it downward down the plane. Assume that it came negative. That means it is up the plane. Shown. Now, when we are writing the equation of motion, we take down the plane positive. I apply the equation of motion, v is equal to u plus at. V is 0, it comes to rest. Initial velocity is 20, that is down the plane. Acceleration is up the plane, so we write minus 1.25 into t. T is 16 seconds. We want to find the s, so we apply v square is equal to u square plus 2as. Although s is equal to ut plus half at, s is equal to ut plus half at square can also be applied. So when we apply v square is equal to u square plus 2, v is 0, u is 20, right? Acceleration is known to be minus 1.25. Yeah. So minus 2 into 1.25 into s. You get the value of s as 160. At a certain instant, a body of mass 15 kg falling freely under gravity was found to be falling at a speed of 25 meters per second. What force will stop the body in 2 seconds? Now, students, if the body is falling freely under gravity, that means it is subjected to acceleration, constant acceleration due to gravity, that is 9.81 meters per second square. When it was falling under gravity, at a particular instant, some upward force is applied on that body so that it comes to rest in 2 seconds. So let's assume that F is the upward force applied on the body to stop it in 2 seconds, right? Now we take downward positive. Initial velocity is 25, so plus 25, v is 0, t is 2 seconds. Apply v is equal to u plus v is 0, u is 25, and time is 2. So you get acceleration as minus 12.5. Minus 12.5 means it is not in downward direction. Acceleration of the body will be upward. So it is under retardation. Now we draw free body diagram of the body. When we draw free body diagram of the body, weight will act vertically down. 15 into 9.81, 147.15. Force F, which is unknown, is applied in upward direction on the body. Acceleration is upward. Acceleration is upward from here, right? We mark the acceleration in the correct direction on the free body diagram because it helps us in applying the Newton's law correctly. Now, acceleration on the body is upward, that is more forces must be upward. So when I apply Newton's law, I'll take upward forces positive, downward negative. Let's apply Newton's law, sigma F is ma. F minus 147.15 is equal to ma. M is 15 into 12.5. That gets you the value of F, 334.6. Okay, let's move to the next sum. This problem also has been asked a number of times in the Mumbai University examinations. Now let's read and understand. 3 blocks M1, M2 and M3 of masses 1.5 kg, 2 kg and 1 kg respectively are placed on a rough surface. Use point 2 between the blocks and the P. As shown in the figure, if a force F is applied so as to give the blocks acceleration of 3 meters per second square, then what will be the force that 1.5 kg block exerts on 2 kg block? Also find force F. Students, you have 3 blocks in contact, namely M1, M2, M3. M1 is 1.5 kg, M2 is 2 kg, M3 is 1 kg. You can draw free body diagram all the 3 blocks as 1 unit, or you can draw FBD of any one of the blocks. If you draw FBD of 3 blocks, normal reaction between the blocks will not come into consideration. They will act as a unit. Whereas if you draw FBD of any of the blocks, then common reaction between the 2 blocks will also come into consideration. Initially, to find the value F, we consider free body diagram of 3 blocks as 1 unit. So we show one box. Total weight of this box is total weight of 3 blocks. 4.5 kg is total mass into 9.81, 44.145. Normal reaction vertically upward, say N1. Acceleration is 3 meters per second square towards right. Motion is also to the right. Friction is to the right. We write sigma Fy is equal to 0. N1 is equal to 44.145. Sigma Fx is equal to Ma. Right? Forces in the direction of acceleration will be taken as positive. F minus 0.2 N1 is equal to M. Put the value N1, right? And you get the value of F. So F is 22.329 Newton. Force is required to cause the acceleration of 3 blocks of as 3 meters per second square. Now he is asking you to find out the force what M1 exerts on M2 or M2 exerts on M1. So that will come into consideration only when the 2 blocks M1 and M2 are separate. So we separate the 2 blocks. We draw free body diagram block M1, right? This is what he's asking. He's asking What is the force 1.4 kg block exerted on 2 kg block? That means it's a common reaction between M1 and M2. To find that reaction, we draw FBD of block M1. Right? We show the weight of block M1 vertically down on FBD, 1.5 to 9.81, 14.715. Normal reaction is vertically upward. F is the external force which is known to you now, 23.329. R is common reaction. Common reaction is equal and opposite between the two parts. It acts towards the body under consideration. This is normal reaction. Motion is to the right, friction will be to the left. Let's apply sigma Fy is equal to 0. When you write sigma Fy is equal to 0, N2 is 14.715 meter. Sigma Fx is equal to Ma. We'll take F as positive. F minus R minus 0.2 N2 is equal to Ma, 1.5 N2. Put the value of N2 into it. And R is unknown, which if you solve the equation, you get the value of R as 14.886. Okay. We could have gotten the value of R by considering free body diagram of M2 and M3 as 1 unit. We could have gotten the value of R by considering FBD of blocks M2 and M3 as 1 unit. All right, let's move to the next sum. Two blocks A and B are separated by 10 meters as shown in the figure. On a 20-degree inclined plane, if the blocks start moving, find the time t when the blocks collide and distance traveled by each block. Assume uk is 0.3 for the block A and plane, and uk is 0.1 between the block B and the plane. Can you see that in the students in the given diagram? There are two blocks shown on the plane, which is inclined at 20 degrees with the horizontal. Blocks A and B are separated by 10 meters. Both the blocks will move independently. Both the blocks will move independently. All right. Now we need to draw the free body diagram of each block. We need to find acceleration of each block. All right. Both the blocks are without dimensions. By applying Newton's law, I can get acceleration of each block. Now, after finding the acceleration of each block, we understand that at the instant when the two blocks collide, upper block B has to travel 10 meters more than the distance traveled by block A. So at the point of collision or point of contact, or when it will be SB will be equal to SA plus 10. This is what we need to. At the point of collision, SB will be equal to SA plus 10. Means distance traveled by block B will be 10 meters more than the distance traveled by block A. Now we draw free body diagram of block A. Block A, its weight is not given, so we took it up, weight as 9.81 Ma. Normal reaction N2. Plane is making 20 degrees horizontal. Normal reaction will make 20 degrees vertical. So we can resolve the weight along the plane, 9.81 sin 20, and normal to the plane, 9.81 Ma cos 20. Motion of block is down the plane, friction is upward. Between block A and the plane, coefficient of friction is given 0.3, so friction will be 0.3. Let's write sigma Fy is equal to 0, N2 is 9.81 Ma cos 20, sigma Fx is equal to Ma. 9.81 Ma sin 20 minus 0.3 N2 is equal to Ma. Right? Now substitute the value of N2, that is 9.81 Ma cos 20. You'll see that Ma gets cancelled from this equation. You get A as 0.59 meter per second square, and it is down the plane. Identically, we draw free body diagram block B. Again, its weight is not given, so we took its weight as 9.81 MB, that is mg. Right? Mass of the block is assumed as MB, G is 9.81. So we have written weight as 9.81 MB. Normal reaction N1 making 20 degrees with vertical. 9.81 MB can be resolved. Normal to the plane, cos 20, along the plane, sin 20. Motion is down the plane, friction is up the plane. Sigma Fy is equal to 0, N1 is 9.81 MB cos 20. Sigma Fx is equal to Ma, 9.81 MB sin 20 minus 0.1 N1 is equal to Ma. Substitute the value of N1, 9.81 MB cos 20. Right? MB gets cancelled from this equation. You get AB as 2. As I discussed, again, I explained to you from the given diagram, block B will collide block A only when it travels 10 meters more than the distance traveled by block A. So at the point of collision, SB is SA plus 10. Now both the blocks acceleration has been found out. S is equal to UT plus half AT square. Both the blocks start from rest. Both the blocks have the acceleration different, which we have worked out. Running time for both the blocks is same. So for block B, when you apply S is equal to UT plus half AT square, use 0, half into 2.43 into T square. For block A, SA is 0 plus half into 0.59 into T square. From this equation, SB value is substituted half into 2.43 into T square, and SA is half into 0.59 into T square plus 10. You get the value of T. All right. From equation number 2, you get the SB distance. From equation number 3, you get SA distance. That's what he has asked in the problem. Now, problem number 7. A vertical lift of total mass 750 kg acquires an upward velocity of 3 meter per second over a distance of 4 meter, moving with constant acceleration starting from rest. Calculate the tension in the cable. Now, students, motion is upward, so I took upward positive. It starts from rest, u0. It attains the velocity of 3 meter per second. We have written as positive. Over a distance of 4 meter, s is also positive. V square is equal to u square plus 2s we can apply since we had SR into consideration. So this is V, this is U, 2as. You got acceleration 1.125 meter per second square. Now, students, as tension in the cable is required, cable is attached to the lift, so we consider FBD of lift. When I draw FBD of the lift, weight of the lift will act vertically down. Total weight is 750 into 9.81, that is 7357.5. Tension in the cable will be away from the lift. That means cable is attached to the lift from the top, so it is away from that. Tension is always away. Acceleration we have found out 1.125 meter per second square upward. Let's apply Newton's law, sigma Fy is equal to m. So T minus 7357.5 is equal to m 750 into A. You get the value of T 8201.25. We'll take one more problem from the same category only, where we will draw FBD of lift as well as FBD of person using the lift. Thus, you observe the difference in the problem. An elevator weighing 980 Newton, including the weight of the occupants, adding up to 196 Newton. That means total weight of the elevator is 980 Newton, including the weight of the persons who are going to use it is 196. Accelerated downwards at 1.5 meter per second. They have given that the acceleration of the elevator is downward 1.5. Find the tension in the supporting cable of the elevator. Also find the reaction of the floor and elevator on the occupants. Now, to find the tension in the cable, we draw FBD of the elevator or the lift. Now, FBD of the lift or elevator, as in the previous problem, weight of the lift will be vertically down, tension will be vertically up, acceleration is downward. We write sigma Fy is equal to ma. When you write sigma Fy is equal to ma, as acceleration is downward, more forces must be downward. So we'll take downward force as positive. 980 minus T is equal to m. M is what? W is weight is 980. 980 upon 9.1, that is mass into A. That gets you the value of tension in the cable as 830.15. Now, second part of the problem, he is asking reaction of the floor of the elevator on the occupants. So in this case, reaction in the between occupants and the floor will come into consideration only when you draw free body diagram of occupants. When you draw free body diagram of the occupants, weight of the occupants will be vertically down. Normal reaction exerted by the floor on the occupants is vertically up. Acceleration is 1.5 meter per second square down. Let's apply Newton's law. Sigma Fy is equal to ma. This time, downward forces will be taken as positive. 196 minus R is equal to m. M is 196 upon 9.81 into 1.5. You get the value of R as 166.03. So we have covered two problems of lifts or elevators. In one problem, we considered FBD of lift. In another problem, we considered FBD of the elevator as well as FBD of the persons using the. Okay. Now, students, we have covered 8 problems. In all these 8 problems, we had the motion of either one body or two bodies, but they were acting as independently. All right. So now we are moving to the problems of connected bodies having same acceleration. Now, in this part, we come across the problems where the two blocks are connected by a string, which is taken around the frictionless pulley, or it is directly connected as shown in the diagram of question number 9. As you can see that for this diagram, you can see that both the blocks will move by same distance. Both the blocks will move by same distance. As the distance moved by the two blocks is same, right? So it is a preliminary assessment or understanding, or that layman's understanding, that if the distance moved by the two blocks in the system is same, then acceleration of the two blocks will also be same. All right. So in this part, we will be drawing the free body diagram of the two blocks connected by a string. All right. Or even if the string is taken around frictionlessly, tension the string will also will be same only. All right. Now I'm reading question number 9. Two blocks A and B are connected by a thread and move along the horizontal plane. Mu is 0.3 under the action of 400 Newton force applied to the body as shown in the figure. Determine the acceleration of the two bodies and tension the thread using Alembert's principle. Now you can see that 400 Newton force is applied on block B to cause the motion, right? There is a string which is connecting the two blocks A and B. Let's draw the free body diagram of each block. To begin with, we draw the free body diagram of block A. Weight is vertically down, normal reaction. Tension the cable is away, that means it is to the right. Acceleration this block is definitely to the right. As motion is to the right, friction is to the right. We should keep it in mind, direction of acceleration and direction of friction have nothing to do. Friction acts in the direction opposite to that of motion, right? It has no relation with acceleration. Now we draw free body diagram, right? Normal sigma Fy is equal to 0, N1 is 200 Newton, sigma Fx is Ma. T minus 0.3 N1 is equal to M, right? Ma is mass, mass is weight upon G. Put the value of N1 as 200, you get one equation, T minus 60 is equal to 20.387. Now we'll draw free body diagram of block B. Free body diagram block B, weight vertically down 800, normal reaction N2, 400 Newton, tension T away from it. String is connected on the left hand side, so tension will be away, that means towards left. Acceleration is to the right, motion is to the right, friction is to the left. Apply free Newton's law on this block. Sigma Fi will be 0, so N2 is 800 Newton. Sigma Fx is equal to Ma. 400 minus 0.3 N2 minus T is equal to Ma. M is 800 upon 9.81. Put the value of N2 in the equation, you get the second equation. Solving 1 and 2. Solving 1 and 2. Right? You get the value A, you get the value of B. As the acceleration of two blocks is same, so we can say that A is 0.981 meter per second square. That is nothing but acceleration of block A as well as acceleration of block B. Because by looking at the diagram only, we understood that acceleration of two blocks will be same. How we understood that acceleration of two blocks is same? Because during the motion, distance traveled by two blocks will be same. If distance traveled by two blocks is same, that means acceleration of two blocks will be same. Let's take next. There is problem number 10. A body of mass 25 kg resting on a horizontal table is connected by a string passing over a smooth pulley. Smooth pulley means tension the string on the two sides will be same. We at the edge of the table took another body of mass 3.75 kg and hanging vertically as shown. Initially, the friction between the mass A and the table is just sufficient to prevent the motion. If the additional 1.25 kg is added to 3.75 kg mass, find the acceleration of masses. Take or assume UK is mixed. Now, initially A is of 25 kg, B mass is 3.75 kg. He says that this 3.75 kg is just sufficient to start the motion. That means when the mass of the block is 3.75 kg, system is in impending motion. The two blocks are in impending motion. If they are in impending motion, that means friction between the block A and the plane will be μs n1, because the block A is in impending motion. In fact, the entire system is in impending motion. That's what it has been said. Now, so first part of the problem will be as that of statics. As statics friction problem we are solving. We draw free body diagram block A. Weight is vertically down, 25 to 9.81 to 45.25. Normal reaction is vertically upward. Tension T towards right. Friction is to the left. Friction is what is μs n. All right. Now, right, sigma Fy is equal to 0, N1 is 245.25 Newton. Sigma Fx is equal to M. T minus μs N1 is equal to M. M is 25 into T. Now, in this problem, as it is a problem of statics, I just repeat that sigma Fy is equal to 0, N1 is 245.25, and sigma Fx will not be equal to M, it is sigma Fx is 0. Because since it is a part of statics. So T is equal to mu s N1. All right, put the value of N1, right? You can get the value of mu s. Now we draw free body diagram block P. Weight is vertically down, 3.75 to 9.81, 36.75, 9 Newton. Tension is upward. Its direction of impending motion is downward, but it is in static equilibrium, impending motion. So we can write sigma Fi is equal to 0 on block B. So tension is 36.79 Newton. This 36.79 Newton T value can be substituted in this equation. N1 can be substituted in this equation. You'll get the value of US. From equation number 1, US into N1. N1's value substituted is equal to T. T value substituted, you get US as 0.15, right? Next. Second part of the problem, he says that when the 1.25 kg mass is added to block B, that means which was initially 3.75, it is now made 5 kg, 3.75 plus 1.25, right? So now the system is in motion. Both the blocks are connected by a string in such a way that both will move by same distance. So acceleration of each block will be same. Let it be, say, A. Now we draw free body diagram of block A. Now we are considering motion part of the problem. FBD of block A, weight vertically down, as over here 245.25. Normal reaction, say N1. Acceleration is to the right, motion is to the right, friction will be to the left. Friction will be taking it as what now? Mu K N1. What will be taking it up? Mu K N1. But here said mu S and mu K are same. So we'll write what we got, mu S as 0.15. That will be taken as mu K. So mu K N1. All right. Acceleration is obviously to the right. Sigma Fy is equal to 0. We can write N1 is 245.25. Then we write Newton's law. Sigma Fx is ma. We write force in the direction of acceleration as positive. T minus 0.15 N1 is equal to Na. 0.15 N1 is 245.25. You get one equation. Now we draw free body diagram of block B. Acceleration of this block will be vertically down. Weight vertically down. This is tension. Sigma Fy is equal to ma. This is weight for 249.05 minus T is equal to ma. Force in the direction of acceleration are taken as positive. Ma. Solving equation number 1 and 2. You solve equation number, this is 1 and this is 2. If you solve this, you can add them up also. If you add them up, T gets cancelled, you get acceleration. All right, or you can use the calculator for solving simultaneous equation. When you solve equation number 1 and equation number 2, you get acceleration, which is same for both the blocks, right? A, once you got A, that is same A and AB. 0.409 meter per second square, right? For block A, it is to the right. For block B, it is vertically. If you want to find tension, you can find even tension also from equation number 1 or from equation number 2. Now, let's read question number 11. Determine the weight W required to bring the system in the given figure to stop in 5 seconds. If at any instant shown 500 Newton block is moving down at 3 meter per second, pulley is frictionless. Students, we draw free body diagram. First, we consider motion of 500 Newton block. You can observe it that there are 3 blocks in the system, but they are connected in such a way during the motion, acceleration of each block will be same. Acceleration of each block will be same. How can you say acceleration of each block is same? Because they will be moving by same distance. To begin with, we consider motion of 500 Newton block. We take downward positive. Initial velocity is 3 meter per second positive. It comes to dash time is 5 seconds. We write v is equal to u plus at. V is 0, u is 3. Acceleration is to be determined into 5. Acceleration is minus 0.6. Minus 0.6 is 0.6 meter per second square. It is not downward, it is upward. So we understand that 500 Newton block is under deceleration. It's under negative acceleration. Now we draw free body diagram of block of 500 Newton block. When I draw free body diagram of 500 Newton block, its weight will act vertically down, tension will act vertically upward, acceleration is upward. So on the free body diagram, we always mark the direction of acceleration correctly. Never work with a negative sign. You understand acceleration is 0.6 meter per second square upward. So on the FBD, you will be showing 0.6 meter per second square upward. Now we write Newton's law on that. Sigma Fi is ma. Force in the direction of acceleration will be taken as positive. T minus 500 is equal to ma. M is weight upon G into 0.6. That comes out to be T as 530.5. Now, on the other side, you have 2 blocks. Is he asking tension the string connecting the block of 150 Newton W? No. So you can take the 2 blocks as 1 unit. As weight of the string is negligibly small, that is what is the assumption of the chapter. Now we have taken FBD of the two blocks of 150 Newton and W as 1. This is the weight of the block 150 plus W. Tension, the string is vertically up. Acceleration is vertically down. Why acceleration is vertically down? For 500 Newton block, it is up. So obviously, for 150 Newton and W, it will be down. Right? Now we write Newton's law, sigma Fi is M. Force in the directional acceleration are taken as positive. 150 plus W will be taken as positive. Minus 530.58 is equal to MA. M is what? W upon G. 150 plus W upon G 9.81 into 0.6. All right. Then cross multiply, solve it. You will find that value of W is 415.1. Now, students, so far the problems, the last time what we solved it, you saw that we took the problems of connected bodies, but we saw that the connection between the two blocks was using a string, which was direct connection between the two blocks, so that by observation only we could understand the distance moved by the two blocks is same. So that's why acceleration of the two blocks will be same. Now we are moving, considering the problems where you'll find that during the motion, distance moved by the two blocks is not same. If the distance moved by the two blocks is not same, that means acceleration of the two blocks will also not be same. So here we are taking up a type of the problems where there is a single string which is governing the movement of connected bodies. So we apply a mathematical technique which is called as constant length of string method. In this technique, we divide the length on which we are applying, the length of the string on which we want to apply constant length of string method. We divide it into segment lengths in such a way that certain segments will remain constant and certain segments will be changing. The segments which are changing, they will govern the movement of blocks. So this way, length of the string equation is written. When you differentiate it once, it gives you the relation between velocity of connected bodies. If you differentiate twice, it gives you the relation between acceleration of connected bodies. Now, to understand the concept of constant length of string method, how we use it, and rest all application of the Newton's law part remains same in all the problems. Only thing is, to get the relation between acceleration of the connected bodies, we use a mathematical technique, constant length of string method. Now, understand problem number 12. At a given instant, 50 Newton block A is moving downwards with a speed of 1.8 meter per second. So this is block A of 50 Newton. It is going downward with 1.8 meter per second at a particular instant. Determine its speed 2 seconds later. He's asking you to find out the speed 2 seconds later. All right. So that means if the acceleration of this block A is known to me, I can simply apply V is equal to U plus A. All right. Block B is of weight 20 Newton. The coefficient of kinetic friction between it and the horizontal plane is 0.2. Neglect the mass of pulleys and cord. Use Alembert's principle. Now, we draw the given diagram as it is. We'll apply constant length of string method on this string. This is the main string which is governing the movement of connected bodies. There's one more string in the system which is connecting the movable pulley and block A. This string is a straight one piece which is not changing its length or anything. We don't need to apply any constant length of string method. Constant length of string method is applied on a string which is governing the movement of connected bodies. So we apply constant length of string method on this string. Now, students, during the motion, this pulley and this pulley are mounted at the corner of these two edges. They will not change position. Only these pulleys will rotate. Only these two pulleys will rotate. All right. Then, when this system moves, distance between block B and center of this pulley will change. Distance between center of this pulley and this vertical plane will not change. Distance between center of this pulley and this plane will not change. So that is B, which is just missed out in the diagram. Distance between center of this pulley and this is B. This is XB, because this length will change and this side we have block B. So this length will consider that it governs the movement of block B. Then distance between center of this pulley and center of this movable pulley. We call this pulley as movable pulley. Movable pulley means what? It is during the motion, it is going to change its position. So such pulleys are called as movable pulley. This pulley is not movable. This pulley is not movable. But this pulley is movable. As what happens during the motion, when acceleration block A is going down, block B will move towards right. So as accordingly, now we apply constant length of string method. What is total length of this string? XB plus 2XA plus B. This is B is equal to constant, right? B is the length of the string which will be changing. It governs the movement of block B. XA is the length of the string which will govern the movement of block A or govern the movement of movable pulley. As you have two parallel segments, we have taken 2XB, right? Size of this pulley and this pulley are neglected as per your syllabus. As per your syllabus, size of the pulley will never be given to you. So XB plus 2XA, XA plus B is equal to constant. Differentiate twice with respect to T. You get it AB plus 2A is 0 or AB is equal to 2A or AB is equal to 2A. So acceleration of block B is 2 times of acceleration of block A. With that understanding, we'll draw free body diagram block B. We'll draw free body diagram of movable pulley. We'll draw free body diagram of block A. Drawing the free body diagram of the blocks and pulley will be absolutely same. The new part of learning in this problem was how to apply constant length of string method. So that we have now understood. Now, let's draw free body diagram of block B. Its weight is 20 Newton, vertically down. Normal reaction is N1. Acceleration is to the right AB, tension. Friction is to the left as motion is to the right. Sigma Fy is equal to 0. N1 is 20 Newton. Sigma Fx is equal to MA. T minus 0.2 N1 is equal to MA. 20 upon 9.81. N1 value you substitute, you get one equation. T minus 4 is equal to 2.039. Now we draw free body diagram of movable pulley. Tension in the main string on which constant length of string method applies is T. So this is T. This is also T. Just a minute, this is like disturbance. And students, let's resume again. Now, we draw first free body diagram block B. Its weight vertically down, normal reaction, tension towards right, friction is to the left as motion is to the right. Applying sigma Fy is equal to 0, N1 is 20 Newton, sigma Fx is MA. T minus 0.2 N1 is equal to MA. M is W upon G, so you got one equation. This movable pulley is massless, right? Tension in the string connecting this two blocks is T. T1 is the tension in the string connecting block A and movable pulley is T1. So sigma Fy is equal to MA. Right? T1 minus 2T is equal to 0 into A. Whereas mass of this pulley, movable pulley, as per your syllabus is 0. So you get T1 is equal to 2. Now we draw free body diagram of block A. Block A, its weight is 50 Newton. T1 is 2T, we understood from the previous part. Acceleration is downwards A, sigma Fy is equal to M. 50 minus 2T is equal to M. M is 50 upon 9.81 into A. Right? A is AB by 2. Right? Now you got another equation, 50 minus 2T is equal to 2.548 AB. Solving equation number 2 and 4. If you solve equation number 2 and 4, you got acceleration of B as 6.336 meter per second square. A is AB by 2, 3.168 meter per second square. After getting the acceleration of block A, now we can consider motion of block A. For motion block A, what he asked that find the velocity of the block after 2 seconds. So we can apply its initial velocity is given to us 1.8. We can take downward positive. V is equal to U plus AT. U is 1.8 plus A is 3.168 into 2, that is 8.136 meter per second. Let's move to the next sum. It's also on the same concept. In the figure shown, two blocks are originally at rest, neglecting the masses of the pulleys and considering the coefficient of friction between block A and inclined plane as 0.25. Determine number 1, acceleration of each block and tension in the cable. You are given with this diagram. This problem also has been asked number of times in the examination. Block A is connected to a string which is taken around the smooth pulley, which will turn around its point of contact. Then it is taken around a movable pulley and then it's connected to a plane. You should understand that this movable pulley, right? This is a movable pulley. Tension in the string connecting this block A and taken around the movable pulley is T. T1 is the tension in the string connecting block B and movable pulley. Now, this is the main string which is governing the movement of connected bodies. We can apply constant length of string method on that. Now you can see that when you apply constant length of string method, you need to draw the diagram. You can see that this is the length of the string that will govern the movement of block A, which will be definitely changing, right? As the motion happens, block A will go up, so this length will change. So we call it as XA. Whatever varying lengths are there, we give them XA, XB. So this governs the movement block A. So I'll call this distance as XA. Distance between center of this pulley and plane remains same. Distance between center of pulley and this movable pulley will change. So that is called as XB. Distance between the center of this pulley and movable center of this movable pulley is XB. So we now write the total length of this thing. XA plus B plus 2XB is equal to constant. Differentiating twice with respect to T, you get A is equal to 2AB. Negative sign you can always neglect when you are applying constant length of string method. Now we draw FBD of block A. When I draw FBD of block A, its weight is vertically down. It is what is 8,000 Newton. What is weight of the block? 8,000 Newton, right? This is written by mistake. It is written 8 Newton. It is not 8 Newton. Actually, it is 8 kilonewton. What it is, students? 8 kilonewton. This is what it is? 16 kilonewton. So this is a printing error. All right. Since it is 8 kilonewton, so this will be what? 8,000 Newton. Normal reaction is N1. Plane is making 30 degree with horizontal. Normal will make 30 degree with vertical. So we resolve it along along the plane 8,000 sin 30. Normal to the plane 8,000 cos 30. Impending this here. Motion will be up the plane, friction is down the plane. We write sigma Fy is equal to 0. N1 is 8,000 cos 30. Sigma Fx is equal to M. T minus 0.25 N1 minus 8,000 sin 30 is equal to M. T minus, so Ma is what? Weight upon G. So you get it. And N1 value can be substituted 8,000 cos 30. So if you simplify all this, you get equation in terms of T and A. T minus 5732.05 is equal to 815.58. Now FBD of movable pulley, this movable pulley, right? Here tension is T1, this size is T2. Same, right? Why TT same? Because it is frictionless. It is also massless, right? It is massless. Acceleration of this movable pulley will be same as that of block B. Sigma Fy is equal to Ma. T1 minus 2T is equal to M into AB. M is 0. So T1 is equal to 2T. Now FBD of block B. When you draw FBD of block B, weight is vertically down, tension T1 is vertically up. All right, acceleration is vertically down. We write sigma Fy is equal to M. 16,000 minus T1 is equal to M. M is W upon G into A. Acceleration is AB. But AB is what? Is A by 2. All right. T1 we have already substituted as 2T. So then you get another equation in terms of T and A. Solving equation number 1 and solving equation number 3. You get T as 7244 Newton and A as 1.854 meter per second square. Once you know T, you can get T1 as 2T and you can get AB as A by 2. Hope you all have understood. So these are the problems of connected bodies where there is a single string which is governing the movement of connected bodies In this type of problems, we can apply a mathematical technique called as constant length of string method to get the relation between acceleration of connected bodies. So this is the part 1 of Newton's law and D'Alembert principle. There will be second part of it where I'll be taking more problems on the same concept, but which will be involving the concepts from other chapters of dynamics as well, right? And so we have 2 more chapters left out as per Mumbai University syllabus, which will be also covered in 2 video lectures. All right. Now, students, if you want to refer to more problems, you can buy my book that is available on Amazon and local bookstores. The link of Amazon is given in the video description of every lecture. All right. Book will be very useful if you want to refer to more solved problems. All right. And if you want to use the MCQs also, as the examination may be online, there may be MCQ also may be there in your multiple choice questions are likely to be there part of your examination. So the book is going to be very useful. Videos are definitely free to all. Even if you do not buy the books, my sincere advice and request to all to share the QR code of the book with as many friends as possible. Because even if somebody does not want to buy the book, it's okay. But at least they can be benefited by watching my video lecture. So please share the QR code so that your friends will also have the access to the to my video lectures. All right. Please subscribe to my video YouTube channel so that you can keep getting the updates as and when the new video lectures are uploaded. Right. I'll finish uploading the Mumbai University syllabus in next 4-5 days time. And then autonomous college syllabus, extra portion of autonomous colleges will also be uploaded probably by 20th of this month. All right. Thank you very much.